It
Yes,
will
sir.
take a
Yes,
so
sir. Okay, sir. Okay. I request you all to on your cameras so we can take a group photograph, please.
kindly switch on your camera so that I can take the picture. I'll take the picture, sir. Vijay sir.
Sure, sure.
Oh, okay.
Mr. Nitin, Miss Richa, Miss Swati, can you please switch on your camera and so that we can take a picture, a group pic. Vikas sir, can you switch on the camera? You are on the screen actually. Okay. Meanwhile, you can drop your call so that we can, take
Miss
a pic.
Richa, Miss Swati, please
Yeah.
on your camera.
Yes. Yes, done. Thank you, all of you. You can switch off your cameras now, and we can start with the proceedings. We just we can take the paper ID number 19 if someone is there. We can start the.
Okay, sir. Now I
Yes,
would
sir,
like
I'm here.
I would like to invite Mr. Nitin, paper ID number 19. Please, sir, you can share your screen and present over there.
Okay, sir. Okay.
Is
Okay.
for all presenters time limit? How much you decided? I think 10
Yes,
minutes is sufficient.
yes, sir. Yes, sir. It's 10 minutes.
Okay, that's fine. Great.
Okay.
Okay, Mr.
Okay. Can you see my presentation, sir?
Yeah. Please.
Okay. Thank you very much, sir. Good afternoon, everyone. I'm Dr. Nitin Kumar Saxena, presently working as Associate Professor in KITE Group of Institution, Ghaziabad. So this is the topic of my paper, reactive power requirement for operating wind-driven microgrid in presence of several proportions and class of static load. The paper ID for your conference is 19. So we are the 5 authors for this paper, along with me, Dr. Varun Gupta, and Mr. Rajsekhar Gupta, Dr. Ashwani Kumar, and Dr. Atma Ram Gupta. So I, on behalf of my all authors, co-authors, presenting this paper. So let us start with the introduction. So squirrel cage induction generators are the most commonly used electromechanical energy conversion device. Can you listen to me? Am I audible?
Yes, sir. You are very much audible. Please go
Okay,
ahead.
thank you so much. Okay, thank you, sir. So when we are going for the studies related with our wind generators, so in wind, like in most of the cases, we are using the different configurations of induction generators, and the most commonly used and preferable because of its ruggedness and the cost. The squirrel cage induction motor is the most commonly used machine for wind applications. And when we are going for the squirrel cage induction generator, we have different kinds of studies which are available through the literatures, and I classified some of them here. Like we have the studies which are related with the types of generators, then the studies related with the reactive power compensation techniques used for these generators, then the control techniques used for voltage control, and finally different types of excitations using special device like FACTS. So if I give a quick review about my paper for the literature survey related with my paper, so I classified these 4 categories on the basis of the references which I used. So you see here, like I showed the number of reference which I quoted in my paper, 3, 6, 7, 16, 18 are the number of references which I used in my paper, and the corresponding year of publishing this paper is given with them also. So the types of induction generators, so I am quoting the general which is cited in my paper at 3, and this paper is published in 2018 and so on. So this is some quick literature review about the topic of my paper. It has been verified that how reactive power requirement for squirrel cage induction generator depend upon the proportions and classes of static load connected with it. And these are the gist of the literature survey by which I got an information that how the different kind of classification of loads uh, like affects the requirement of reactive power for squirrel cage induction generator. And the different device, the basic device which may be used for this squirrel cage induction generator excitation is fixed capacitor, which is also known as commonly static compensator for fulfilling the reactive power for the system. So if we go for the cost analysis using the static compensator, so we have the basic formula for the static compensator fixed cost as given by this R multiplied with reactive power required from the fixed capacitor. And when we go for the mathematics, then the value of R for the 15 years of life of expansion, if we are assuming for the fixed capacitor, then it comes out to be 0.132 multiplied with QFC, which is being used in my paper. And as we know that the loads may be classified in different categories, and the most commonly or one of the most commonly used method is the ZIP model. The mathematically ZIP model is represented by this blue highlighted equations for real power as well as for reactive power. Then we are putting the different values of K1, K2 and K3, similarly K4, K5 and K6. We can get a different classifications of our load model. Though the polynomial is not so like it's a popular, but for the realistic approach, if we use the exponential method type of the load, it may gives a most realistic picture about our load. So if we put our load in the form of exponential type like given over here, and we are changing the exponential component, so by putting the different values of NP and NQ, we can get the different classifications of the load. And for this purpose, I use these five kind of the load component: the air conditioner, resistance heater, lighting, pump, and large industrial motor. And for these in literature, I got the values of NP and NQ over this. However, if we put the value of NP and NQ by 0, 1, 2, then we can again get the value like constant Z or I or P kind of model. So this is the simple model which I use to get the reactive power for our system, in which I use a induction machine, and as I want to uh, use it as a generator, so I uh, calculated the torque required for this machine, and I gave the negative value of the torque by which this machine is working as a generator. And for this, I'm putting a load from the Simulink model, three-phase dynamic load, and there is the option for changing the value of NP and NQ. When I'm changing the value of NP and NQ, it will behave like a different loads as per our requirement for this paper. And this is the capacitor bank, so we can give the different reactive power, and the system will work. So how we proceed? For proceeding, I used a machine of 4 kilowatt, 400 volt, 50 hertz squirrel cage machine, and I operated it 4% negative slip so that it can work as a generator. And first of all, I put a one iterative M code, the MATLAB programming, through which I tried to get the torque for which this machine will work for the exactly 4% negative slip, and reactive power estimation. This I calculated for the different classification of the load. So for different loads, the reactive power estimation will be different. So from my MATLAB programming, I received the different value of the reactive power according to the load. And for getting the different results, I put up some mathematics over here that when we are putting the load 75%, 85%, 95% or 100%, and the different kind of loads like air conditioner and whatever. So I got the value of reactive power in each case, as well as when I got the value of reactive power, then mathematically I got the value of the reactive power cost also. So this is the graph which the values are calculated by using the MATLAB coding as mentioned over here in methodology. And for this, I tried to get the plots, and by these graphs, we can conclude that how the reactive power requirement is changing and for the different loads. So we can conclude in this way that estimation of reactive power for excitation of self-excited induction generator or squirrel cage induction generator has been done using exponential load model for the different types of commercial loads along with the calculation of cost in each case. From these results, it can also be calculated that as the load percentage increasing, more or more reactive power is consumed by induction generator to maintain the constant voltage and torque, and so does the cost of static capacitor. So induction generator is more suitable to supply the light load so that the cost of reactive power remains low. This study can help in estimating the reactive power requirement on the basis of load behavior and characteristics. And the distribution companies and generating companies, in case of decentralized power plants, will be able to decide the tariff of individual consumers based on their load components and characteristics. In future studies, the dynamic load conditions can also be examined with advanced compensating device connected with distributed generators. STATCOM and SVC can be used as compensating device in place of a static capacitor to supply the reactive power. Further analysis could be done by making use of different generator schemes like BSCF or BSBF for advanced studies. Also, we can perform composite load analysis, which is the combination of static and dynamic load. So, thank you very much. This is all about the presentation about my topic. So,
Okay, that's great, Professor Nathan. Nathan, I have two queries. First,
yes,
whenever we do research, there is always comparison with some previous research. Certain person did that, and we performed that. From that, we can conclude that our research is somewhat better or somewhat differentiating result or similar result. Have you made any comparison with previous results?
actually, sir, in this model, like I tried to get the iterative procedure for getting the reactive power requirement on the basis of the load. So, if I talk about this particular paper, so in this particular paper, I didn't compare the previous studies. However, I have done that part in my other papers, sir.
Okay. Okay, you are extending in that direction for
Yes,
journal.
yes.
Okay.
That I have already done, sir. But in this paper, I am not quoting that part, sir.
Yeah. I can understand that is always part further extension is required for sending to the journals.
Yes,
And secondly, just I want to check. There is always some implications of research. Whatever you do, there are always some implications.
yes, sir.
That was missing in your presentation. Can
Yeah,
you?
yeah.
Yes, please.
Yes, sir. Actually, sir, I'm working on the deregulated electricity market, and I'm also approaching to make a center of excellence for this in my college. And this is the part like I'm working on the value-added ancillary services. So in value-added ancillary service, as you know, sir, there are 12 ancillary service, and the active power compensation is one of them. So,
Yeah.
when we are talking about the tariff, so normally we are talking about the tariff which is related with real power consumption based. So the purpose is that we will also the reactive power, like someone can say that yes, we will take the reactive power by using the statcom only, but at the same time the consumer cannot be like comfortable by taking the power from statcom because it will be very costly. So
True.
the process is that like we are trying to satisfy the reactive power by using the simple static compensator at, up to the extent till the system will allow us, and later on we will go for the reactive power by using the advanced devices. So in I'll tell one thing, sir. So in my one previous paper, I have worked on it. That paper is already published in one SCI, in which I gave a margin that till what extent I can use fixed capacitor, and after that I required statcom, etc. So in this particular paper, I tried to get the reactive power on the basis of the load classifications. So
Okay.
like I'm focusing on the realistic load kind of things in this.
Realistic load. Okay. You mean to say just like smart grade something you are doing for particular load based upon load, right?
Yes, sir. Yes.
Okay. Okay. Any query from the participants?
Okay, if there is any query, kindly ask so that we can move to the next one. Okay, thank you, Nitin sir. Thank you for the presentation.
Okay,
Thank you, sir.
now
Thank you so
we
much.
can proceed for our next presentation. Paper ID is 42. Miss Richa, Miss Swati, and Miss Sanya, you can now present your paper. Thank you, Nitin sir.
Thank you so much, sir. Thank you, sir.
Miss Swati, Miss Richa, now you can present your paper. Okay, thank you.
Hello.
Yes,
Yes.
ma'am, you are audible.
Okay, so the topic we've worked upon is the study of performance and emission characteristics of biodiesels with nano additives. It's a review paper comparing various biodiesels with nano additives.
Sania, ma'am, you are going to
Yes.
present the paper, is it?
Yes.
Okay, please.
So, energy is one of the most important resources for mankind and its sustainable development. Uh, Today, the energy crisis is becoming one of the global issues confronting us. Developing nations like ours are experiencing increased international pressures on these issues of global warming and emissions. Hence, renewable resources and cleaner alternative fuels have received increasing attention for current and future utilization. Biodiesels, also chemically known as fatty acid methyl esters, those are produced by chemically combining any natural oil or fat with methanol and ethanol by esterification, can be used and is being increasingly used for these purposes. Uh, Due to high viscosity and incomplete combustion that triggers higher smoke density when compared to fossil fuels, which leads to poor fuel atomization, crude oils are not suitable for directly usage in diesel engines. Hence, esterification and thereby reducing the viscosity is necessary. And the byproducts of biodiesel production, like glycerol and all, finds extensive use in industrial applications. So the feedstocks for various biodiesels can be classified as either edible or non-edible oils. In these studies, both of them have oils from both categories have been considered. There have been nine oils that we've considered for this. Metal-based nano additives are generally added for fuel performance enhancement, and hence some of those considered in this study are aluminium oxide, cobalt oxide, etc. The aim of the study is mainly to identify the most suitable nano additive from those considered and its quantity for each category of oil in terms of imparting best performance and emission characteristics for further studies to be aimed in this direction for commercial production. Also, the change of properties in the biodiesel, such as density, calorific value, kinematic viscosity, and all, are observed for various blends of biodiesels containing varying amount of nano additives to account for their practical feasibilities. This being a literature review article, about 30 papers have been reviewed, but due to the format constraint, I wasn't able to include all of them. So what we see here is one nanoadditive for each oil that gave the best outcomes. It can be observed that most of these follow a similar trend, wherein both performance and emission characteristics are improved with some exceptions.
Sir, is it audible? Hello?
Right?
Yes, Dr. Karthikeyan, thank you.
Sorry for the delay. Sorry for the delay, sir.
It's okay, sir. Miss Sania Chauhan is just presenting the paper. It is just second paper of the this track. Should we go ahead, sir? From the middle.
Track 5. Just now I received the message that is you can join in track 5.
Yes, sir. This is track 5, and this is the paper number 2 in this track, sir, which is being presented by Miss Sania.
Okay.
Should we go ahead, sir, with this?
Yes, sir. Go ahead, sir. And how many number of papers are now available?
Sir, there are total 9 number of papers to be presented in this track. This is the second one, sir.
Okay, wait, sir.
Okay, Miss Sanya, you may go ahead, ma'am.
Okay, sir. So as I said, it can be observed that most of these formula follow a similar trend, wherein the performance and emission characteristics were improved. Percentage changes of which have been given on the next slide. For Jatropha oil, we considered aluminium CNT, cobalt oxide, aluminium oxide, cerium oxide, and graphene oxide nanoadditives. For this biodiesel, cobalt oxide of 100 mg per liter concentration gave the best output. Decrease in various emission and performance characteristics have been given, like by about 2.1% in brake specific energy consumption, by 0.6% in BT at full load conditions. 1% by volume ferrofluid gave the best output for Pongamia biodiesel, though radium oxide additives too imparted increased enhanced thermal efficiency. Due to reduced uh, emission characteristics, the decision was made. Similarly, for neem biodiesel, aluminium oxide was considered. For cottonseed with cerium oxide, aluminium oxide yet again for Mahua biodiesel. In this, what we see is for Mahua oil biodiesel with aluminium oxide, what we see is though hydrocarbon and CO emissions are being decreased, consequently 7.95% increase in NOx emissions was observed. For palm oil biodiesel, silver oxide was concluded to be the best. Cerium oxide for grapeseed, aluminium oxide yet again for soybean biodiesel. So the general trends observed can be attributed to some of the given reasons. Higher viscosity and lower volatility of biodiesel causes it to undergo incomplete combustion, and hence performance of the fuel is lower than that of neat biodiesel. Nanoparticles provide a relatively larger surface area to volume ratio, hence promotes better combustion properties, thereby making nanoparticles ideal catalysts to be used as additives in fuel. Another reason for the observed trends is that nanoparticles disperse throughout the fuel and encourage better homogeneous air to fuel mixture. Some of the exceptions that can occur, like we observed in the NOx emissions for Mahua biodiesel with aluminium oxide, it's because addition of nanoparticles above a certain ratio causes difficulties in fuel vaporization, thereby promoting incomplete combustion, and as a consequence of which various performance and emissions start declining. Therefore, selecting an optimal range for nano additives is the key to get good results in enhanced performance and reduced emission in CI engine. Agglomeration, that is the clogging of nano additives in base fluid, is yet another major problem in the way of fully utilizing nano additives commercially. In conclusion, based on the available literature of said oils, D20 blend of Pongamia oil biodiesel blended with 1% by volume ferrofluid of oil considered blend gave the most favorable trends of performance and emission characteristics. The further studies can be focused on this combination. The work can be done to obtain an optimum ratio of nanoadditive to be blended with the biodiesel, or by varying the compression ratio, etc., to obtain enhanced results. Some other factors for drawing this conclusion and to consider Pongamia oil biodiesel as a possible additive to diesel for commercial uses is because Pongamia is a non-edible oil, and the production of biodiesel from edible oils has always been a good option, but it is not commercially feasible. The residual of Pongamia biodiesel production, like the tree barks and leaves, etc., find widespread use for medicinal purposes. Karanja is highly tolerant to high salinity conditions and can be grown on most soil textures, and it's one of the most potential oils for production with capacity of over 13,500 million tons per annum, out of which only 6% is being utilized as of now. And viscosity of Karanja-based biodiesel is within the limits of ASTM specification of biodiesel. Its calorific value was found to be lower than that of diesel because of the lower oxygen content, but is satisfactory for running engines when blended with diesel. The flash point of Karanja biodiesel is higher than that of neat diesel, hence storing the biodiesel blend is safer than storing diesel alone. And properties of Pongamia biodiesel resembles that of diesel closely. So no engines, others engine alterations are needed for using this in the commercial users in the commonly available vehicles. That is all I guess.
Okay. Query from Dr. Andre Kujmin. Yes, Dr. Andre, please ask, please. Yeah.
Yes, I have a question.
Yeah.
Could you please tell me what is the error level of your measurement tools and the overall error level of the system?
Sorry, sir. Wasn't able to comprehend.
Okay, I have to repeat it.
Yes, sir, sorry, I wasn't able to present the question.
Okay. Do you have any values of the systematic error of your measurement systems?
So this is a review paper and not a research paper, so I don't have the error calculations.
Okay, this question is concerned to one of your slides where you show that some parameters have changes very little, around 2%, 5%. Yes, in previous slide, 0.6% increase in BTU. But this is very, very low change, and the measurement tool must be very accurate for take this.
So these values have been taken from other research papers that have been published.
Okay, I see. Thank you.
Okay. Any query from participant? Yes, please.
Yeah, just I want to talk to that participant. So I am a Dr. Karthikeyan. Can I interact with that person?
Yes, sir.
Hello.
Hello.
Yeah.
Yes, Dr.
What is the name of?
Sorry, sir.
What is the name of the biodiesel?
So which biodiesel? 9 oils have been compared in the study, as I said.
No. What biodiesel you taken?
So we haven't taken any biodiesel.
Hello?
We have compared. Sorry. Yes.
What, sir? Hello.
Hello.
Please, you can you show the title?
Sir.
Yeah, biodiesel means, well, you mentioned which biodiesel, madam? Which biodiesel and which additives you have taken this?
So we've considered 9 oils.
Yeah, 9 oils. Which are the edible and which are the non-edible oils?
So non-edible oils include Jatropha, Pongamia, neem, and cottonseed oils. And yes.
Now it is now the biofuel is in the 4th generation is going on. Why you are taking this is the 2nd generation of the bio?
Sir, I'm not able to hear you.
What? Hello.
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 Yes, sir.
Yes. Okay.
Hello.
Hello, please tell me. Hello.
Yes, sir.
Yes, madam. Please tell me why you are taking this now. The biofuel is 4th generation is going on, but you have taken only that 2nd generation. It is an old work now. And what are the nano additives you have taken?
So the nano additives, the aluminum oxide, cobalt oxide, basically metal-based nano additives have been.
Material based. What is the combustion temperature of the nano additives? Do you know that? Is it after combustion, it is a complete combustion, or it will maintain inside the combustion chamber?
So I guess it's released with the exhaust gases.
No. Try to understand my question. You should know before using that nanoadditives, first we should know the combustion temperature of the nanoadditives. Because the combustion after the compression, the temperature is around 1600 degrees centigrade. But our selection of the nanoparticle combustion temperature should be less than 1600. That only it will make the complete combustion inside the combustion chamber. Otherwise, it is not possible. It is clocking that everything, nozzle and flow pipe and everything. Have you found that value of the combustion temperature of the nanoadditives or not?
So this is
No.
just a review paper. We've not
Taken a
considered
review.
that.
Okay,
Yes.
are you a research scholar or ME, Master of Engineering?
It's a with BTech students.
What BTech?
Yep.
BTech student.
Yes, sir.
Okay. Better. I will just. I have nearly published around 70 SE papers in the biofuel area and engine testing. My name is Karthikeyan. You can go through the Google citation and you can refer more papers. And
Yes, sir.
do you want any doubt regarding your projects? You can contact me. I will help you. Don't worry. Okay, but
Sure, sir. Thank you.
don't do that old one. You taken as a old one. But and now the all energy conversion is going to that electric vehicle. Just
okay, sir.
to focus on this biofuel, but it should be, and most of the latest trend in the biofuel is algae. So algae biofuel is the latest trend is going on. Please, if you are doing that project in this biofuel means you can take it as a third generation is better. Third generation means the algae. Algae means you have to focus only the microalgae. Okay. But anyway, all the best. Okay, carry on.
Okay. Dr. Sanya, I have one query. Whenever we do literature review, there will be always some review criteria. What was the review criteria?
Sorry, so what review criteria?
For example, what were the keywords? What databases you have searched? Just what was your criteria for reviewing these papers? Why only these 25 papers or 27 papers?
உங்கள் முடிஞ்சல உள்ள இருக்காளா இன்னும் முடியலையா?
Dr. Karthikeyan, please mute your mic. Yes.
Just muted me.
So,
you can reply.
So we've used the generally used biodiesels that have been studied upon.
Okay.
That are mostly studied upon, and as I said, metal-based nanoadditives to whatever nanoadditives we were able to get.
Okay, thank you. Thank you. Okay, next
Is
one,
there
please.
any other queries from anyone else? So Vijay sir, we can go ahead with the next ID.
Okay, thank you, Ms. Sania Chauhan. Before we proceed for our next presentation, now I would like to introduce our co-session chair, Professor Dr. S. Karthikeyan. So Dr. Karthikeyan is working as a professor and head of the department Mechanical Engineering in Syed Ahmed Engineering College, Tamil Nadu. He completed PhD in Mechanical Engineering in 2015, ME in Thermal Engineering in 2007, and BE in Mechanical Engineering in 1995. His area of specialization includes thermal engineering, solar power technology, internal combustion engine, and biofuels. He is having many prestigious publications in national and international journals of great repute. In his rich academic experience of 20 years, he has supervised many MTech and PhD scholars. Also, he has contributed as a resource person, advisory committee member, and as a reviewer of SCI and Scopus Index journals. He has also been the editor-in-chief for the same. So I feel deeply honored to share his rich profile with you all. I welcome you, sir, on behalf of ABES EC family. Dr. Karthikeyan.
Okay, thank you, sir. Thank you so much.
Thank you for joining us, sir. Now we can proceed for our next presentation. Paper ID is 44. Ms. Payal Sharma, you can present your paper. You can share your screen now. Miss Payal Sharma.
Okay, sir. Okay, sir. Yes, sir. I'm sharing.
Oh,
Sir, is it visible?
Yes, ma'am, it is visible. Just make it on presentation mode.
Okay. Am I
Below.
audible?
Yes, ma'am, you are
audible.
audible, ma'am.
Okay. Good morning to one and all present here. I, Payal Sharma, am pursuing my PhD from IGDTU, Kashmiri Gate, Delhi, from Mechanical and Automation Engineering Department. And the topic of this review is competency of alcoholic fuels as diesel blends. And the co-authors of this paper are also mentioned here, Dr. N.R. Chauhan sir, Associate Professor from MA Department IGDTU, and Dr. Manish Adakar sir, Associate Professor from ABES EC. So these are the outlines of the paper that I'm going to discuss. So the basic introduction is, so diesel
Sorry to
engines as
interrupt you,
we
ma'am.
know.
Payal, ma'am, can you take it
Pardon?
on your presentation mode? It will be.
So
You
is
can go
it
top left from beginning. You can click from beginning. Top left.
top left?
From beginning, you can click from beginning. Yes.
Is it fine, sir?
Yeah, press F5. You press F5, then it will enlarge.
Yeah, you can press F5 also. It will be in
F5 mode,
presentation.
then you can enlarge your slide. It's in compact mode. You can enlarge
Yes,
the
sir.
slide.
So I have pressed F5.
Okay, you can do one thing. There is a from beginning written over there. Top left from beginning. You can click that.
Yes, sir, I did that.
You click it.
Yes, sir, I did that.
Okay, it's not. Then we can go ahead with this.
Is it not visible, sir? Okay, sir.
Maybe there is another window in which it is open already.
Okay, sir.
You can do one thing. You can again share the PPT.
Yes, sir. I'm
Yes.
just doing that again. So I have to share my desktop. Is it okay, sir, now?
Madam, the bottom side, you have one slide, one option is in the bottom side, bottom of your PPT, then you can press it, madam.
So my screen has shared. Okay, slideshow from the beginning. Okay, is it okay, sir?
Yeah.
Okay. Okay, so this is the outline that I'm going to discuss in this review. So the basic introduction is that, as we all know, that diesel engines, they produce, they are the major air pollution source, and they produce a lot of emission that is responsible for climatic changes. So we need to focus on how can we reduce the emissions and increase the performance as well. So nowadays, many researchers are being focusing their work on alternative fuels, as well as many researchers are focusing their work on adding some nano additives and some kind of alcoholic blends or biodiesel blends with diesel, so as to improve the performance and reduce the emission. So I have focused my review on the alcoholic additives that are being used for the diesel to reduce emission as well as to improve the performance. So through my research, I've seen that the alcoholic fuels, they have a high octane number, but they have low cetane number. So what can be done, like for gasoline fuels, it is good because it enhanced their octane rating, but for diesel fuels it reduced their cetane rating. So we have to use some cetane enhancers with diesel like peroxides, nitrate, esters, azide, and ethers. So if we have to use cetane enhancers along with we add alcoholic fuels, but these cetane enhancers also produce some effects on emission also. So basically it has to be a compromise that how much to be added. So miscibility issues usually come when we add alcoholic additives with diesel, like mostly phase separation is observed with primary alcohols. When we blend ethanol and diesel or methanol with diesel at low temperature, usually we observe phase separation. So, and homogeneity is also an issue. So it is troublesome, and we have to look for that what other things can we add to improve the homogeneity of ethanol and methanol with diesel blends, that is with primary alcohols. However, among all the alcohols, butanol has some superior property. It dominates over ethanol and methanol as diesel blend because it forms a better blend even at low temperatures also, and no phase separation is observed. So the cetane number, it basically is a specification that indicate the self-ignitability of the fuel, and the cetane number of butanol is high as compared to the primary alcohols. The cetane number of primary alcohols is already low, and although the butanol also decreases the cetane number of the diesel blend, but amongst the primary alcohol, the cetane number of butanol is high. So amongst all the alcohol, if we can say, butanol is a better additive option for diesel because no phase separation is there, and even at the low temperatures, and the cetane number is also high as compared to the primary alcohols. Although ignition delay period, it can be reduced on the addition of cetane enhancers. So what happens, we have to add cetane enhancer when we add alcohol to diesel. That is because cetane number will be reduced. So we have to add the cetane enhancer. And cetane enhancer also reduce the ignition delay period. So it also helps in that. So as we keep on increasing the cetane number, the NOx and the carbon monoxide, sulfur dioxide emission, they also have seen to be reduced with little increase in soot though. So alcoholic additive, basically they play along with the cetane enhancers so as to boost the ignition characteristics. So if we need to add alcoholic additive with diesel, we have to add cetane enhancers, although butanol has superior property amongst all the alcohol. But then also if we need to add alcohol with diesel blend, we have to add cetane enhancer. Limited solubility in diesel, but we can improve those blends by adding certain additives or emulsifiers or even the cetane enhancers. Higher alcohols, they have better solubility with diesel as compared to the primary alcohols, and they also form stable blends at low temperature, where methanol and ethanol, they cannot form stable blends at low temperature, even though we can improve that by adding certain emulsifiers. So methanol, ethanol, they possess low flash point also than diesel, which is a barrier in terms of safety, and butanol has high flash point amongst the primary alcohol, for which it is safe to handle, and it is also less corrosive than the primary alcohols. That is why when I went through many research papers, and I've seen that many researchers have used butanol with diesel, and many researchers have also used methanol and ethanol, but then they have used some cetane enhancer or some emulsifier or additive with it. So I've summarized all the alcoholic fuels like primary and few secondary like higher alcohols. I've summarized the results. I've been through papers and I've seen that what can be the barrier if we are using alcohol like methanol and ethanol, what can be the barrier to it. So I've summarized it in a table. So basically cetane number of alcoholic fuels is low. So when it is added to diesel fuel, the cetane number is always decreasing. So I've seen that it adding alcoholic additive to diesel always decreases its cetane number. So for that we are adding the cetane enhancer. That is why. And the emissions, as per the emissions, there is difference like when we add methanol, it gives reduction in smoke and carbon monoxide emission and reduction in NOx emission, but little bit increase in carbon monoxide and HC emissions. Similarly, in ethanol, we are seeing that reductions in particulate matter and sulfur oxide emissions, also NOx and CO emissions, were also getting minimized, but total HC emissions were less than that of diesel fuel. So every alcoholic additive has some different effect on emission. Whereas for the properties also, methanol and ethanol, as we discussed, are immiscible in diesel fuel. So solubility issues are always there with methanol and ethanol. And the barriers for using the methanol and ethanol is, first of all, low flash point, which is drawback for safety, poor fuel economy, low ignitability, and low calorific value. And with butanol and propanol, I have found limited issues that are coming up, and even the issues that were coming up are being resolved. So very less barriers for propanol and butanol were there. But for isobutanol, isobutanol has low cetane number, so it can worsen the auto ignition capability of the fuel. And reductions were found in every case, but in some case soot was exceeding. So this is how I have summarized it in a table. Sorry, my slide is not good. Okay, so what can be the solution for the miscibility issues? I've gone through alcoholic fuel additive papers. So the solution can be, for primary alcohols, many researchers have used biodiesel along with ethanol when mixed in diesel. So the biodiesel improves the solubility, but due to its poor cold flow characteristics, at low temperature it poses problems because it increases the viscosity. So that is why biodiesel can be a solution to the problem of solubility of ethanol and diesel, but it also poses problems in cold weathers and low temperatures. And similarly, this poor cold flow characteristic, high viscosity, low volatility, it makes biodiesel unsuitable with diesel in cold weather conditions. Otherwise, it's okay to improve the solubility of ethanol and diesel. And similarly, methanol can also be added to biodiesel diesel blend. It upgrades the characteristics at low temperature and increases the oxygen content also, and minimize the particulate matter emissions also. Now another issue, now when we are blending methanol to biodiesel and diesel blend, it improves the characteristic at low temperature, but it reduces the cetane number of blend, so it affects the self-ignitability of the fuel. And isopropanol, it is having high cetane number. As per from the primary alcohols, it has better miscibility in diesel and better option as compared to methanol and ethanol or the primary alcohol. So many researchers have suggested emulsifiers also other than biodiesel. So many researchers have said that if biodiesel poses problem at low temperature, we can also use some emulsifiers with ethanol and diesel blend to improve the miscibility. But there is always some issues with ethanol and methanol. That is the primary alcohols. So conclusion is, the primary alcohol, they always pose some troublesome behavior, and we need cetane enhancer to improve the miscibility issues always. And cetane enhancers, they are always required when we mix the alcoholic additive with diesel, and it also improves the ignition delay, so it is always required there. So alcoholic fuels have to play along with cetane enhancers in diesel fuel. And butanol, on the other hand, it has superior properties amongst all the other alcoholic fuels, and it can be further probed to find that what other proper blends can be formed from that, so that we can reduce the hydrocarbon emission, which is still increasing, because in butanol diesel blend still soot is increasing and hydrocarbon emission is increasing. So what other blends can we mix with butanol to improve that? So we still have to probe that. So these are the references. Thank you, sir. Hello, am I audible?
Hello. Yes. Thank you, Payal. Any query from the audience? Yes, please. Any query?
Yes, can I ask?
Yeah, please, sir.
Okay, I have a couple of questions and very.
Hello.
Hello.
Yes.
Yes,
Yes, sir.
madam.
Yes, sir.
Yes, madam. What are the alcohol you have selected, madam?
Pardon, sir, there's some noise coming from.
Have you selected higher order or lower order as well?
Sir, this is some noise is coming from somewhere.
Dr. Karthikeyan, too much voice
Yeah.
is coming from your side. Too much voice. Noise.
Hello, is it okay? Hello.
No, sir.
Sir,
No,
pardon,
sir.
Pardon, I haven't.
Have
got
you
the question.
selected? Which one you selected, madam? Higher order or lower order as well?
Sir, through this research, I have found that butanol has some superior properties, and if I have to choose, this is a research review paper. So if I have to choose a blend for diesel, I will choose butanol because it already has some superior properties, and we don't had to improve its solubility problem with diesel. So if I would have to choose, I would choose butanol. It is a review paper though.
Review paper was only you are doing only that the review only, not an work.
Sir, this is a review paper. Although I'm working to find out an alcoholic blend for diesel, but this is a review paper only.
Okay. Well then, all the best. You do it your research.
Thank you so much, sir.
Okay, Dr. Andre, please ask your question, please. Sorry for the interruption. Yeah, please.
Okay, thank you very much. It seems Dr. Kadrikian voice is on the rail station. So much noise from there. Okay, I have a couple of questions, both of them concerning the cetane number and the emission. In one of the first slides, you mentioned that increase in cetane number leads to decrease in emission. Could you please explain what is the reason of the emission decreases?
Yes, sir. Sir, actually, I've been through many research papers, and I've seen that when you increase the cetane number, the ignition delay period is getting reduced, and because of that, the temperatures are not rising up to that level where NOx emission formation takes place. So this is the kind of reason for reduction for NOx emission, and because proper combustion takes place, because the ignition delay period is reduced, so that is why CO emissions are also getting reduced.
Not understandable. The increase in cetane number should lead to the increase in the temperature. Am I right?
Increase in cetane number. As I'm not very sure about this.
Increase in cetane number of the fuel leads to the process that ignition of the fuel became in more temperature than usual. If the temperature increases, the main source for nitrogen oxides is the temperature. So, with increase in cetane number, nitrogen oxides must be increased. This is just a remark.
Okay, sir. Okay, sir, I'll see to it. I haven't paid much attention to this. I'll see to it.
Okay, at least you can check how the researchers explain this phenomena.
Okay, yes.
And the next question, again with the NOx emissions, could you please show the last summary? Maybe not last summary, but table revise again. Yes, this. No.
Yes.
Okay. For all type of fuels you enumerated here, the cetane number decreases.
Yes, sir.
Again, if cetane number decreases, the temperature inside the engine decreases. And decreases in NOx confirm that. So the question is, if we decrease the temperature inside the combustion chamber, the thermodynamic efficiency of the engine should be decreased as well, and the overall the overall efficiency of the engine will fall. What do you think about this?
So that is why alcoholic fuels cannot be added alone to diesel. We always need some additives, emulsifiers, or like cetane enhancers with them.
Okay, do you have any papers with the results where the efficiency of the engine with the details was investigated?
Yes, sir. The research papers that I've been through for this review are there, and in those papers, like basically not for methanol and ethanol. With methanol and ethanol, all the researchers have probed an issue that the emissions are like soot is somehow increasing, some emission is decreasing, and soot is increasing at the same time. So, but with butanol, usually emissions are getting reduced.
Yes, but what about the efficiency of the engine? Not the emissions, but the
Yes, sir.
efficiency.
Yes.
Do you know?
Yes, sir, I'm getting. Yes, brake thermal efficiency was somehow increasing by 1 or 2% mostly, not much more than that. And BSFC was also increasing.
Okay, thank you.
Okay, thank you so much, sir.
Thank you, Amjad sir. Is there any other query to ask? Or should we go ahead to the next ID? Dr. Sunil, do you have
Yes,
anything
yes.
to ask?
No. Please go ahead.
Okay, thank you, Payal Sharma ma'am, to present the paper.
Thank you. Thank you so much, sir.
Mr. Akash Saxena and Akash Yadav, who is going to present all of you, sir?
Yes.
Mr. Akash Saxena and Akash Yadav, you have paper ID number 71 for design of variable brake force mechanism.
Yes,
Am I
sir.
audible to you, sir?
Yes, sir. Yes, sir. Is it visible, sir?
Yes, sir, it is visible. Just to make it on presented mode, sir.
Yeah.
Yes, sir, it's fine now. You may go ahead.
Okay, sir. Well, good afternoon to all of you. My name is Akash Saxena, and I'm a final year student of Mechanical Engineering Department from ABES Engineering College. I'll be presenting the paper submission number 71, Design of Variable Brake Force Mechanism, with Akash Yadav, who is also a student of ABES Engineering College. So let's begin. As we all know, braking is an essential component of any automobile. The purpose of braking system is to slow down a vehicle or completely stop it. Usually, it is done by rubbing a brake shoe or a brake pad against the wheels and reducing its speed by friction. Depending on what method you choose to bring them in contact, you can classify them into different types. Here, we'll talk about the hydraulic braking systems. Now, when we talk about braking, two terms, the brake force and the rate of braking, needs to be understood. Brake force is the force applied to the wheels to inhibit its motion. The rate of braking is the ratio of brake force to the weight of vehicle. As you can see here in this diagram, a hydraulic braking system consists of a brake booster, a master cylinder, and the drums or caliper and discs depending on its type. Here we have shown the caliper and disc. Now, if we ignore the external factors for such a system, the rate of braking is almost fixed and we have no control over it. In our paper, we have talked about a variable brake force mechanism which can offer two different rates of braking. To understand how we did it, let's talk about the design of a variable brake force mechanism. The variable brake force mechanism adds a new component to the system, a force multiplier. The force multiplier works on Pascal's law. When you apply force at the inlet, it generates pressure, which is transmitted and it pushes the cylinder outwards. It has four components: the inlet cylinder, the outer cylindrical shell, the cover, and a locking mechanism. The inner cylinder can slide freely inside the shell, and the shell can slide within the cover. There are flaps on the side of the shell which limits its travel and prevent rotation. There is a lock on the upper right corner, you can see. It locks the outer shell and prevents any movement. There are grooves on both the shell and the cover for the O-rings to prevent leakage. And there's a hole in the lower left corner which connects it to the reservoir. I think now everyone has made a rough guess, so let's talk about its working now. The arrangement of the mechanism is as follows. The plunging action at the inlet is provided by the shaft of the booster, and the master cylinder is directly in contact with its outlet. Now, there are two scenarios which offer different ratios of the multiplier. Here, the multipliers that we have chosen is 1 and 3. Let's assume the driver has pressed the button for 1. In this case, the outer shell is locked. When you press the pedal, it applies force on the inlet of the booster, and the outlet shaft of the booster moves outward. This movement provides the plunging action, and the inner cylinder moves outward. Now, since only the inner cylinder moves outward, the brake force is transferred as it is, and then the brake is applied. As you can see here in this animation, you will get the basic idea. Now, let's talk about when the outer shell is unlocked and the multiplier chosen is 3. When the driver chooses the multiplier 3, the outer shell is unlocked. When the pedal is pressed now, both the outer shell and the inner cylinder move like a larger solid cylinder. The area at outlet becomes 3 times that of the inner cylinder, and thus thrice the force is transferred to the master cylinder. As you can see here, the lock is open, and now when the plunging action takes place, both of them move simultaneously. Now, let's talk about the methodology, the design constraints, and how we actually designed this force multiplier. Akash, please take over. Hello, Akash. Akash, can you hear me?
If I think he is not able to say something, so you can go ahead. You can continue.
All right, then I will continue. We first began with the idea of providing different force at outlet for the same inlet force to design this force multiplier. So we came up with a concentric cylinder arrangement. The booster shaft had to provide the plunging action, so the inlet diameter was the same as that of the shaft. Now, for the force multiplier 1, the area at outlet and inlet both had to be the same, so the diameter of the inlet cylinder was also kept the same. For force multiplier 3, the force at outlet needed to be thrice, so the radius was calculated using this relation. Then the other parameters were decided, like where the O-rings should be placed and how much space we should give to the fluids, etc. And now, as you can see in this calculation, we have shown here, the force from the booster was taken to be 3500 Newton. It varies from 3000 to 3500. So we have taken the maximum. And the diameter of the shaft was kept at 30 millimeter. The pressure exerted is force upon area, which came out to be 4.951 megapascals. Now, there are two conditions, as I stated before. For the first condition, when only the inner cylinder can move, the outlet diameter was kept at 30 mm, the diameter of the inner cylinder. So the force exerted was the same, 3500 Newton. In condition 2, when both the outer and inner cylinder can move, the outlet diameter was kept at 52 mm, and the force exerted at outlet is pressure into area, that is 10,550 Newton. We calculated the ratio, which is approximately 3:1. It is 3.004, so we rounded it off. Now, about the analysis. Okay, Akash, I guess you're back. So,
Yes, I'm really sorry about the internet issue, but I'm back now.
go ahead, please.
So after the design was completed, we did the structural analysis of the parts, namely the outer shell and the cover. The inner wall and the base of the shell was subjected to a pressure of 5 megapascal, which will be generated when brake force of 3,500 Newton is applied by the brake booster. The result of the analysis showed the maximum stress generated for cylindrical shell was 17.44 megapascal. And for the inner walls of the cover, they were subjected to a pressure of 5 megapascal, and the result of the analysis showed the maximum stress generated was 9.583 megapascal.
So now we have seen that the force multiplier provides two values of force for the same input force. This results in two rates of braking. Now, I'd like to talk about why we need two different rates of braking. You see, different terrains require different rates of braking. On a slope or a muddy terrain, it is better to have a higher rate of braking. For a highway, the usual rate of braking is sufficient. If you talk about the modern vehicles, the modern vehicle come up with different modes which adjust the vehicle responsiveness in a variety of ways, from less responsive but fuel efficient eco mode to the more aggressive sport mode, which gives you a keenly sharp response of speedy driving. But when you talk about these changes, the changes that the sport mode or the eco mode bring, they are limited to transmission. With the introduction of the variable braking mechanism, when we change modes, it brings about a more comprehensive change in the vehicle. Thus, the variable braking systems offer more flexibility and convenience. And I think they can be explored further to improve the automobile technologies. These are the references, the books and the paper that we referred to during the course of our work, as you can see. I'd like to end the presentation here. Thank you very much.
Thank you, Akash. Dr. Sunil, sir. Yes, sir. Your query,
yes,
please.
Akash, I have one query. How it is different from previous one? Because this analysis was made by many researchers. What is difference between your model and previous model?
Yes, sir. I know there have been many different versions of these variable brake force mechanisms, but you see, there the issue was the change that you bring, the change in ratios that was brought about with hard braking and soft braking. When you press the brake down to the bottom, at that time the sudden increase in pressure changes the braking rate. That is the main trigger in those mechanisms. Here we are giving the control to the driver with the help of a switch, and when you press a button, it goes from eco mode to sport mode, the transmission changes, the brake changes, and it brings a more comprehensive change. So it's different from those mechanisms.
Dr.
Okay.
Andre, you want to ask something? I think he has raised the hand. Can we go ahead with Dr. Andre's questions?
Yes, sir. Please ask.
Okay. At first, a little remark. Please, for the next time, use the legal Windows software instead of the pirate copy. Is okay? Your Windows is not activated, and this was shown in your slides. It is not bad, but it is not good. Do you understand me?
Yes, sir, I do. I'll try harder next time, sir.
Okay. The question in regard with your presentation. At first, in my view, this is very interesting work. Thank you. And I'm proud to be involved in listeners of this presentation, of this development. It is very interesting. But I have some little doubt of it. The brake system of the automotive is very important, maybe one of the very important systems. Any increase of its complexity will lead to decrease of its reliability. Could you please tell me what do you think?
Yes, I understand your question, sir. That I understand, and that is precisely the reason why we introduce a new component. You see, there have been different works, and many a times they make changes in the brake booster. And I'm sorry to say, but there was some people who actually made changes in the master cylinder too, and there were US patents also on it. But I think that the master cylinder should not be touched so easily. It is much better to introduce a new component in its place. See, a new component ensures that even in its failure, you can just separate it out. As you can see, it's an independent component, so it won't be an issue. But making changes directly into the master cylinder will undoubtedly increase its complexity and will increase the chances of accident. So here it is much better, and there the changes in rates of braking were being made in hard braking and soft braking. Now, when you press the brake pedal, softly, at that time you are just decreasing the speed. But during hard braking, it's usually done in case of sudden braking or in case of an accident. So at that time you cannot afford a failure of brakes. So that is why I think our mechanism is more durable, because once the cylinder is locked, even on a highway, when it is giving a force multiplier of 1, it's not an issue. Even if it's giving a force multiplier of 3 when it's a rocky or hilly terrain, it won't be that big of an issue, because it is not interfering in the process of braking in any manner. It is just increasing the force. So that is why I introduced a new component. Anything else, sir?
Okay, thank you. And very close to the previous question, but it relates to the human feelings. When we push to the brake pedal, we usually expect the properly response from the system. If we need, at some moment to prevent accident, for example, the additional cylinder begin to work, and the forces of the brake system is increased, it can be unexpected for the human, and this can lead, for example, to its maybe health danger.
Yes, I can understand what you're trying to say, but you see, when you change from an eco mode to sport mode, the main purpose was to link it to the sport mode and eco mode and the different modes of an automobile. So when you go off-road and when you change the modes from eco mode to sport mode, let's not talk about racing on the highways and changing the sport mode for leisure. But when you actually change terrains and you change from eco mode to sport mode, you actually need a more comprehensive change. You expect a more comprehensive change. So as a user, I would like my car to be more beastly in nature, to bring about that change, so that I can feel the power, and along with that power I can feel more control. When you go from eco mode to sport mode, at sport mode you are able to unleash the complete power of the engine. The transmission works completely well. So in that case, if you have a higher rate of braking, so I think it would be a better option, and it won't lead to accident, but it will be more satisfactory.
Okay, I see. Thank you. The young is the development.
Okay, thank you, Akash.
Okay, thank you, Akash. And Navendu sir, we have any presenter now, or we have finished?
Let us ask from the participants if there is anyone left and present over here. Please say, otherwise we will end this session.
Yes.
Is there anyone who is going to present the paper?
I think all
I
have
think there is
presented.
no one left, sir, who is present
Uh,
over here. You can end it. The thank note from your side, sir. Please go ahead.
Okay. Thank you, sir. Okay. Before we go for a conclusive remark, I want to request you all please join at 4 p.m. for the valedictory section, and the link for the same has been sent to your email. So please join. So now we conclude our remark. Yeah. Hello.
Dr. Karthikeyan, you want to say something, sir? Dr. Karthikeyan? Dr. Karthikeyan, am I audible to you, sir? Do you want to say something?
As an organizer, can you just mute him?
Yes, sir. I think so. He is not, audible to us also.
Wow.
Okay.
Which is we can.
Okay. Thank you, sir. Now we conclude our remarkable, memorable, and knowledgeable event track 5 FIT 2020. I like to thank all the presenters, our session chair Dr. Luthra, our co-session chair Dr. Karthikeyan, and our guest Dr. Andrew Kuzmin. I like to thank Navendra Pratap sir, who track beautifully, who manage all the things in this track beautifully. Thank you, sir. I like to thank our colleagues, Gaganpreet ma'am, Manish Saswat sir, and Dr. Vikas Vadoria sir, to join this session. Now, we promise you all that in the coming years, we will enter in the fields with some more innovative ideas to nourish your mind. Thank you. Thank you so much, all of you. Thank you, sir.
Thank you, sir, for joining this session. Thank you, Anush sir, also. He was left.
Thank you.
Thank you.
Thank you. Bye-bye.
Thank you. Hope these proceedings will help research community to think innovatively on new research ideas.
Definitely.
Yes, sir. Thank you for your.
Yeah. Thank you.
Thank you. Okay, please be join at 4 p.m. for valedictory session. Again, I'm requesting you. The link has been sent to your mail. Please join all of you. Okay. Thank you, everyone. You may leave now. Thank you.